So hello, and it's Miriam here from the Institute of Refrigeration, back with our second episode of our podcast, The Tip of the Iceberg. And this week we're talking to Brian Churchyard. Brian's a member of the Institute of Refrigeration, long-term member since I believe that he joined the industry. And he can tell us a little bit about how he got into the industry and what he's involved in at the moment. Thank you all for joining us, and I will hand over to Brian.
Hi, good morning, everybody. Brian Churchyard. I've always been involved in refrigeration from my early days as an apprentice back in the early 90s. Very proud of my engineering roots and background, certainly within the engineering sector, the service engineering sector. Best practice is something that's close to my heart from an engineering perspective. You know, do things the right way first time. It's surprising how well things work. Moved on to a project management role within the same organization, then moved on to refrigeration consultancy role. And the last 16 years, I've been working for a large end user in the UK, Asda, and at the same time, working with our parent company in Tullamore recently, Walmart, but pretty much a full career across the commercial refrigeration sector. I also look after for Asda the energy profile, energy savings initiatives, and also more recently the net zero program. So moving significantly beyond refrigeration, so to speak, which is what this conversation really needs to start to become.
Brilliant. Thanks for that little plug there on Beyond Refrigeration. That's what we're here to talk about, really, because Brian and I have been chatting with the Institute's Beyond Refrigeration group for a couple of years now about the whole concept of net zero. I mean, and this is almost, I think, perhaps before the government in the UK even came out with this aspiration of net zero, talking about whether this is really achievable or, what it's doing. So, I mean, let's start by saying, asking you, Brian, what does net zero mean for you?
So more so now than ever before, holistic approach to engineering, connected data, connected analysis, connected evaluations across various different initiatives. We talk to a net zero position, but I think there's also a bit of reality around near net zero. I think we need to be honest with ourselves around how we get to a purest net zero position, purely from an engineering perspective, and what other initiatives need to be attached to that, probably in the longer term, where you're looking at carbon capture initiatives, so on and so forth. So I think it's very much around connected industries, not just the refrigeration industry, but pulling it in from mechanical, electrical industry as well, your HVAC areas, and how you get a holistic view of how building performance comes together, rather than it just being looked at in isolation.
Yeah, and that's what I'm hearing time and time again, that, you can't talk about net zero refrigeration. It has to be a much broader discussion. You have to even look at right the way through from where the energy is coming from, where the resources are coming from. We're having lots of discussions about things like circular economies and things like that.
Yeah, when you start looking at your scope 3 emissions as well, from a emissions perspective, then you really start getting into what are the supply chain doing and how do they connect into that. How do our customers connect into zero emissions? What does that mean from a business operation perspective? So when you look at your scope 1 and scope 2 emissions profile, from refrigerants to energy consumption, and then layer into that scope 3, all of a sudden you have to look at a much bigger picture.
Can you just explain to the listeners what scope 1, 2, and 3 is? Because I'm not even that familiar with those.
It's a framework in which is used across pretty much most industries, which kind of defines different categories of emissions. So if you look at scope 1, 2, and 3, so scope 1 would look at, and scope 2, if you combine the two of those together, would look like at emissions from things like carbon produced from electricity consumption, carbon produced from a fleet of logistics, carbon produced from emissions of refrigerant gases. So scope 1 and 2 is kind of more business focused in terms of what you can do as a business to reduce your emissions. And then that framework is then layered into targets and requirements that need to be met. When you then look at scope 3, it's a much, much broader view of emissions. So scope 3 then starts incorporating your supply chain that works for you. So as a large end user, we have a vast supply chain, whether that's from an engineering provision perspective or through to our product on our shelves. So all of a sudden your scope 3 emissions starts then drawing into your total emissions footprint significantly greater than just your scope 1 and 2 emissions as a business. Probably up to anything 90% of your emissions will probably sit within your scope 3 emissions. And this is why everything that you look at around net zero, you have to think beyond your business. You have to think about how is the impact of your business? What is the impact of your business around your supply chain as well? Because that will then be drawn directly into your emissions footprint. But the conversation around refrigeration is equally relevant to your own footprint as it is to your external supply chain footprint. And how do you share that information and opportunity?
So net zero really for people working in a retail or environment is a real thing. It's not just a nice idea. It's not just something that you have to do on top. It's going to go through the whole of the business operation. I mean, it sounds as though you've actually got real targets that you're working towards on it.
It's inevitable. It forms part and parcel of your business strategy going forward. It's a requirement ultimately. And how do you achieve that? But in the most cost-effective way possible, because we still have responsibility to our customers to ensure, especially now more so than ever, we are ensuring that our customer is achieving the best value they possibly can within everything that surrounds emissions reduction. The more cost-effective we can make the technologies that we bring into ours or other organizations, the more of it we can do, the quicker it can be done.
And going back to one of the things you said about it going, this idea beyond refrigeration, it's not just one person's responsibility. One of our themes has been working together. How do you see that? Is that one of the most critical issues about how you work everybody's working to the same agenda, everybody being able to share data or share approaches or, looking for new ways of working together?
Yeah, if you look at it from an environmental perspective, it serves no purpose doing things in isolation. Sharing data and sharing information is critically important where we can. Obviously, there are some sensitivities around that. It's not sharing information at any cost, but certainly a collaborative approach in sharing information, being open-minded in terms of technology and application. Speak about it many times in other areas and forums around taking a technically neutral, technically agnostic approach, whatever that might look like, but with the ultimate aim to come up with technologies and innovation that reduces carbon output, is simple technology to apply, which is cost effective. As I said before, the more cost effective and more value it can add, the quicker it can be applied, the quicker we can get there. So I would say that the collaborative nature, being at the table for the discussion, having an open mind, being led by the data and the facts that are in front of you are critically important.
So who do you think should be working together, to get a little bit more specific? Is that across industry sectors or that more of up-down approach and working with your suppliers and working with the customers?
To be blunt, sells tins of beans. The industry and the engineering industry across the board have got the responsibility and hold the keys to the castle, so to speak, in terms of what those technologies of the future could look like. So there's only so much that we could do as an end user in terms of facilitating and helping connect the dots in terms of collaborative working. But ultimately, then also the responsibility sits within the different engineering sectors to then create that equal collaborative environment on the same level. At the end of the day, we facilitate, a large supermarket organization for us like ourselves. We're doing the things that we can do to impact and drive things forward, but we need to ensure that those technologies we're adopting are best value engineered, low carbon, flexible technologies, and ultimately that needs to come through innovation from the industry.
And one of the things that I'm sure you did mention there was about direct emissions. So again, I know from work we'd done together way back on the Institute's Real Zero work that you'd taken you said zero tolerance approach to leakage. So which do you think is more important, your direct emissions or your indirect? That's a trick question, but go for it.
Yeah, absolutely. And I think it may be a trick question, but an important one, because if you treat both of them in isolation, you can argue the points either way. Everyone can build a business case around a direct emissions strategy. We can build one around an indirect emission strategy. For me, the answer lies in both, that you bring the combination of both indirect and direct emissions together, giving you a total equivalent warming impact. Then you start understanding the wider issue and the wider challenges that we face. We then layer into that, what does the decarbonisation of the national grid begin to look like? So that then has a fundamental change in your emissions from your indirect emissions that you're looking at. So then you need to project it out to the future. So when I'm looking at lower carbon refrigerants, I'm looking at a decarbonised national grid. What does that then look like if I project it into the future? So bringing both of those numbers together has got to be considered. It can't be, if I look purely at high carbon refrigerants as a direct emission and I get rid of that problem, I've therefore got rid of the problem, because I'm decarbonising the grid anyway. Because led into that conversation has got to be energy consumption. So if you look at direct, indirect carbon emissions as a total, you then need to understand then what does my energy profile look like in the future? Am I up? Am I down? Am I equal to? So you would very quickly get into an evaluated measure of data across a matrix, not just one or the other. You then consider things like safety of these systems, safety of the types of refrigerants. There's no getting away from the fact, as you reduce the global warming impact of a refrigerant, you increase the volatility of those refrigerants, whatever it may be. And that always becomes a challenge. So then you layer into it, what does safety look like in a matrix of measure? So you very quickly start moving away from, if I choose this refrigerant, everything's fine, or if I choose this type of system on energy profile, everything's fine. All things need to be considered in equal measure.
I mean, I was going to say it's a balancing act between direct and indirect emissions, because, or say energy use and refrigerant emission, because, I've heard people say in the past that as the efficiency and the other things go down, you can still reduce your direct emissions, but they become more important because they become a bigger slice of the cake of the emissions. But actually, from what you've said, it's a lot more complex than that, even because of not just the safety, but also new technology, things coming in, and the grid. It becomes, and this, I think, why people struggle to get their heads around it. It's such a major issue. How do you pull it all together?
Yeah, it's a balancing act to exactly that point. And this is why I say, when you look at a near net zero position, if we jump forward to 2040 or 2050, there will be a near net zero position. So you then also have to consider, what do the carbon capture technologies look like for that residual carbon that will remain in place, whatever refrigerant it is that you have. But what links into all of this that's key is back to containment of refrigerants. Has to link to containment of refrigerants, because those residual emissions in a future world are only relevant if it's based on a leak rate. It's not relevant necessarily if it's in the system. It's not the refrigerant that leaks, it's the systems that leak. This then loops itself back around to engineering best practice, do the right thing, all those types of different things. So regardless of the type of refrigerant, leakage and containment of those systems has to be an equal measure at the top of the agenda.
Yeah, and this one of the things that I hear a lot of people saying, some of our leading trainers always say to me, but it's basics, it's back to basics. It's just get the system working properly, and the system should never leak, or should not leak, or at least leakage should be absolutely minimal. So if you get those basics right, everything else will just follow on.
Leads back into my opening statements around following best practice, and it's amazing what can actually happen and that doesn't just mean best practice from design through initial installation deployment, but best practice through the life cycle performance of that system. It's important that engineering best practice is followed through to end of life, and that's something to be proud of within an industry, within a sector, that a sector is behaving in that way. So you mentioned the zero tolerance behavior. Zero leakage is an aspiration. We would love to get to zero leakage, but if we instill a zero tolerance behavior within a sector, within the industry, irrelevant whether it's a refrigeration industry, heating ventilation industry, we have that tolerance to zero leakage installed, then we've got more chance of getting to a smaller possible residual number that we can.
And do you think that then we need let's say a culture change, getting away from the hard skills, the engineering thing? We know what needs to be done and how, because through a lot of the tools that are available, people are aware of what the engineering solutions are, or the way the approach is to get to that minimal. But it's the behavioral, years, I don't know, 10, 15 years on from real zero, we're still talking, or I'm still hearing people say about best practice in leakage reduction. Is this just about training, or is it about attitudes, do you think?
Attitudes. I think perfectly honest, I get a little frustrated sometimes when we target engineers as being one of the root cause problems of their skills. I certainly know when I was in the service division and service engineers I speak to today, these guys are highly skilled and they have a difficult job to do. While we're all tucked up in bed at 2 o'clock in the morning, while the sun has gone down, these guys are out there sometimes on their own, fixing some quite major engineering issues out there to make sure that our stores are up and trading the following morning, and magically there doesn't seem to be an issue. We need to probably have a bit more of an understanding that the challenges that these guys face on a very regular basis, especially when the sun comes out, are very difficult. So whatever that technology of the future looks like has to be with that in mind. It has to be in mind with the complexities of keeping our food available to the general public. It's a service as well as a profitable business to be providing food. And we've just seen that through the pandemic, how important supermarkets are to the general public. So I think there is, we can train, we can give guys the tools, but I think we also need to recognize a level of respect to that engineering fraternity that they have challenges, in order to not just deliver technology that exists and evolved, but then we're layering challenges on top of that to then change that technology to something else. And going, there you go, you've not just got the historic challenges that you have to deal with, there's now a bunch of new challenges you have to deal with in the future with technology that's less known. I just think we just need to be mindful of that these guys have got big challenges for the life cycle of the performance of that equipment.
And then, they're not miracle workers. They've got to work with what they've got and the time that's available and the budgets and all the rest of it. But it still keeps coming back to that. If people are not familiar with the Beyond Refrigeration work we've been doing, where we identified 7 or 8 different areas and things like heat recovery and life cycles, but also trying to get that soft skills in, looking at education and working together. And that really does tie in with what you said there about it's, yes, okay, you get the fundamentals and the education, but the working together is trying to get away from this blame culture, and that often seems to be a bit of a barrier. It's their fault because they didn't give us enough time, or they used the lowest quote. It's their fault because they're in a hurry and the people didn't employ skilled people. It's, whilst we still blame each other, we don't make any progress. I think that's the frustrating thing from our point of view.
Yeah, the refrigeration industry is complex. A design engineer to an install engineer to service and maintenance and commissioning engineer, they all actually see refrigeration from slightly different perspectives, which is unusual because it's the same sector. But I mean, we always, and when I say we, in terms of what we do in our organization, we always try and work hard to connect those different areas of the same sector. So designers are speaking to the end user, are speaking to the installer, are speaking to the service and maintenance teams to make sure that everybody is able to have their say, so that the output ultimately means that something that sits there for the foreseeable future is agreeable to all those different areas. And that comes back to your, what can we do as a sector to then work towards these goals? And it goes even further than just connecting different sectors and industry, but also connecting the different disciplines that sit within those same sectors to all work towards the same set goals.
Yeah, because it's particularly going back to the engineer, it's about the design of the system and the designers understanding how the systems work. But moving slightly on then into areas of one of the questions I want to ask you, which you, again, I don't know whether it works for you, but what do you think the world is going to look like? How different is it going to look for the retail sector in the future as we move towards that net zero, as we try to work in different ways? Can you see Any insights?
I mean, it's always a fun question to try and answer. I guess you ask 10 people, you get 10 different answers. But I think, we know that the world is kind of online grocery, and that, again, with everything that's happened around the pandemic, has shown significant progress and movement within that sector, within within food retail. So that is likely to be there for the foreseeable future and continue to grow. That then creates, by default, innovation in a different operational structure for businesses in terms of what equipment might be used, what type of facilities these online grocery sector will work from. If you're looking at from a building perspective as a traditional food retailer, I mean, you just all you have to do is look at eco design directives and the F-gas regulation and the net zero challenges. And what we need to be working towards is more efficient systems with lower refrigerant charges, with much lower carbon impact that's associated to it. How do you get there? So you start including things like doors on chill display cases? Does that become more of a requirement than this is an opportunity?
Now you're getting really controversial when you start talking about doors, because that one just goes, it sounds like an easy solution, and it's like all of these things, it's never easy.
No. Well, from an engineering perspective, it certainly is easy, because what it gives you is significant reduction in refrigerant charges, significant savings in both energy from a store heating and refrigeration perspective, and less refrigeration plants to operate those systems, to operate the same linear meters. Where it becomes a challenge is from a retail perspective, because we're then stepping into the realms of challenges around for the customer, in terms of our stores get incredibly busy at peak times at Christmas, and our chilled aisles become very busy and very congested. So we have to balance what does that mean from a operational perspective for the business. But that's not to say that we don't look at these opportunities and shouldn't look at these areas of big opportunity. And I think when you look at, like, say, certain regulation that's already starting to take hold and coming down the line, there's a certain inevitability to these things. The F-gas regulation, low carbon refrigerants, it's inevitable because that's the purpose of the regulation. So when we start looking at things like doors on chill display and these types of things, and achieving net zero profiles, trying to do things that can be done in the future for reducing energy impacts, we see the rates are eye-watering, the rate increases eye-watering. You need to kind of have an eye on, well, what could this look like? Outside of all the challenges, there will always be challenges that exist around it, but then also how does innovation help overcome that?
So you've got that multi-pronged thing. You've got one on the one hand, you've mentioned a couple of legislations which are driving the industry, and the environmental legislation. You've got the environmental objective of businesses, and I think it's a real change we're seeing in the last couple of years of businesses are not just there for shareholder value. Obviously, that's important because they are businesses, but they also have these other corporate social responsibility that is driving business.
It is. And, if I look at my role in my organization, my job is to flag these opportunities, but then also help the business in trying to find ways to overcome those challenges. That's the fun thing about engineering. Engineers are always presented with challenges and problems to overcome. So, right, this fixes these 3 issues, but we've now created 2 more. How do we now overcome that? And it's a never-ending iterative process of development, rather than just to stay in the same place or fix yourself to the ground with one solution. It's about how you create a flexible, innovative environment that also then supports value engineering further down the line, or lean specification further down the line.
Yeah, I mean, this is what, one of the things that always concerns me is that people are saying, well, which is the best refrigerant? What we need to do is get down to having 1 or 2 refrigerants in the future. It's too complicated, and all those sorts of issues. But actually, it's never like that. It's only ever getting more complicated. And that's why it keeps people in our industry, I guess, because they know that they have the knowledge to understand what's coming up and try to work it through. If it was always the same, it would get a bit dull anyway, I guess.
Technology innovation doesn't work like that. The way it works is new ideas, new opportunities, trial, evaluate, move forward, and then it happens again. An analogy around VHS versus Betamax. In the 80s, those remember in the 80s, that would it be VHS, would it be Betamax? well, it's an irrelevant conversation because we now stream video. Who would have ever thought in those days that we would be talking about, well, you don't need to buy anything really that is as tangible as a cassette tape that goes in the machine. You just basically turn the TV on and there you go.
Yeah, I think we've all got DVD players sitting in the corner that we haven't used for 2 years, haven't we? It's crazy.
Exactly. Yeah. And innovation will continue to be exactly that. It will become, it will continue to provide options and opportunity in different direction. And we can't shy away from the fact that I've mentioned it twice now, that the technology needs to be as cost effective as it possibly can. I'm not decrying away from, environment is incredibly important. Environmental sustainability is incredibly important. The more we can make it financially sustainable, the more we can do and the quicker we can do it.
We're nearly running out of time here. Can I finish with one question then for you? What do you think people can do on a personal level to make change happen, to get us to that future? Any advice on, not a business thing, a personal thing?
Be at the table, be open-minded, don't shy away from the things that might seem overly challenging, and understand that everybody is probably coming from a slightly different position, even within your own sector. Be in a position where you kind of say, how can I help that? How can I help you, rather than that's not my problem, that's someone else's problem. It has to be an environment where everyone starts working together.
Yeah, owning the problems is a really good way to go forward.
Yeah, it can't be a discussion around a 2-horse race on 2 different types of refrigerant gases, because it's too one-dimensional in terms of that's all we're looking at. It has to be the whole thing ultimately. And also, one solution for one large end user may be completely different for another large end user. It's not necessarily going to be the same solution for everybody, because the architecture that sits within any given large estate, that a supermarket, it is what it is because it's been developed over decades and decades to become whatever that infrastructure looks like. So just because one end user may be doing something slightly different to another doesn't mean it's wrong. It means it's relevant to their business. And that's why I say it needs to be an open-minded approach and learning from each other. Why I do what I do is not why somebody else would do something, purely because of the architecture of their estate.
But that's all the point of what we're involved here at the Institute of Refrigeration, is to get people to share some of those different approaches. So when people have a blank sheet of paper, they can say, okay, well, there's doing that, what works for me, and give them those options.
Completely. Yeah, it becomes a shopping list of opportunity,
Thank you very much for that, Brian. I think we're about out of time on that one. It was really good, and hopefully we'll come back, maybe next year or later in the year and pick up on some of those themes again and continue the work on containment. The next podcast we'll be looking at skills, and we're taking that into a little bit more depth of all those difficult issues around improving skills, attracting new people to the industry, and I'm sure we'll be picking up on that idea of working together again and employers supporting trainees. So thanks again, Brian, and we'll see you soon.
Thank you. Bye-bye.
This was the tip of the iceberg from the Institute of Refrigeration, and I'm Miriam Rodway. We hope you're enjoying our podcasts. Please like and share and follow the podcast, and join us on the next edition.